Welcome to the Copernicus Data Space Ecosystem webinar with a focus on Copernicus Sentinel satellite imagery for ship spotting. In this webinar, Andrzej Zlinski will take you through the possibilities of detecting the vessels with open data, how to find ships in satellite images, how to read the image of a ship or a port, how to understand the size and environmental impact of ships, and more. So without further ado, Andrzej, I'll hand the mic over to you.
Hello, everybody. Thank you for joining today. I'm Andrzej Zlinski, originally a conservation biologist, moved into remote sensing, but I also used to be a dinghy sailor, and with this came an interest in ships. So today I would like to talk to you about identifying and understanding ships through satellite imagery. What we have on our front page right now shared with you is Copernicus Data Space Ecosystem. This is the data portal for Sentinel satellite imagery, open satellite data that anybody can look at. On this portal, we also have a gallery, so a collection of interesting images, which is a nice way to get acquainted with satellite imagery. If you have never heard of satellite imagery before, what we use is a network of satellites operating a couple of 100 kilometers above the Earth's surface and collecting images at regular intervals in regular places. So this means that every 5 to 10 days, we have complete coverage of the Earth's surface, and we can see a lot of interesting things happening on these images. The tool we use for this purpose is Copernicus Browser. So browser.dataspace.copernicus.eu. This is the starting point for exploring satellite imagery. You will see that you can zoom into the images. You can just click Show Latest Date. It's going to pull up the latest satellite image of the area that you have on your front screen. And then you can select between various visualizations, and you have a calendar panel for looking at imagery from different times. So compared to the typical like Google Earth or Bing Maps overview that you get with an image that's updated maybe once a year or so, these images are updated every couple of days. And so this means that you have the option to select an image exactly from your time of interest. So this is why we use Copernicus Browser. But why watch ships? Well, ships are a major part of our economy. A lot of the goods we buy and use and the food we eat is transported by ships around the planet. And so this means that shipping has a major environmental and economic impact. And understanding this, having a sort of a personal feeling for this, is something that watching ships on satellite imagery can contribute to. Of course, it's fun. Ships are beautiful. They have names. They sort of have a personality. And so it's sometimes exciting to spot a special ship. For a lot of people, shipping is a cultural thing for their country or their family. But there's also a big fact-checking aspect to ship observation. Sometimes you can validate news, you can verify reports of things that happen, you can track illicit activities through what we call open source intelligence, and environmentally relevant processes such as garbage cleanup or pollution or fishing can also be found. So this is what we use for taking a look at ships. But what do we use for collecting information, knowledge on ships? Well, there are some open sites that collect information on ships and their positions. One of them is marinetraffic.com. Every ship is required to carry a transponder, what's called an AIS, and this system reports the position of the ship regularly. So this information is public, and it's possible to track it using these sites. So marinetraffic.com is one, and Vessel Finder is the other. This has a relatively nice map interface, which is regularly updated, and every single ship can be checked. And if you click on one of them, then you get information about the ship, where and its current location and heading and port calls. So these are the tools that we use for understanding the activities of the ships in addition to satellite imagery. And it's always a nice thing to verify the position and activity of a ship based on these sources. So let me show you an example. This is just a screenshot from Vessel Finder. This is the port of Bremerhaven. So what we see here is the dock, and we have a list of ships that are there at this specific time when the screenshot was taken. We have Arroyo, which is a major cruise ship. Some of the basic information from the ship is here as well. It's 336 meters long and 52 meters wide. And if we pull up a satellite image of the same time and date, so this is the the 6th of December at the moment. And so on the 5th of December, this ship was moored here in Bremerhaven port. And we can check just by measuring its length. Yes, this is close to 360 meters based on the satellite image. We can identify this cruise ship as Aroya. And up here on the other end of the dock, we have some container ships loading. These little blocky patterns are very typically containers, which have a rectangular shape and come in all sorts of colors. And the second ship from the north is Petersburg, which is actually one of the world record holders by size. So this ship is just under 400 meters long. And with this simple satellite image tool, you can observe it being loaded with containers. And you can also compare it with the size of objects that you know, such as buildings or houses. So this is literally something like a whole street moving around the ocean. This is the typical or the maximum size of ships that regularly travel around the world. So this is one way to collect basic information on ships. Now I want to talk to you about how to understand satellite imagery of a specific ship. Let's check this example. This is the aircraft carrier USS Gerald R. Ford in the middle of the Mediterranean Sea. So what do we see here? Obviously, this is a top-down view of the ship. The pixel size of this image is 10 meters. That's the resolution which our satellite is operating at. The superstructure is casting a shadow on the deck. The ship is casting a bit of a shadow on the sea. This is the bow, the front of the ship. This is the stern, and this white part is the wake of the ship. So the water that is moved, churned up by the activity of the propellers. There are different ways to look at satellite imagery. Sentinel-2 imagery also has infrared bands which have a slightly better signal-to-noise ratio. So although it appears darker, the edge of the ship is somewhat crisper. In some conditions, this is a nice way to identify the ship. We also have highlight optimized natural color. You can see that with compared to the true color. Let's wait for this to load. The markings on the deck are a bit easier to pick out because this is highlighting the difference between the bright and the dark colors a bit more. And then there's one more trick here. There is some smoothing applied to the image. So the neighboring pixels are slightly smoothed into each other. Under effects and advanced options, if we go to nearest upsampling, then you see it gets a lot blockier. But if you actually zoom out, then this means that the contours of the ship are a lot crisper and easier to understand. Let me give you another example. This is a ship sailing through the ice in the Gulf of Finland towards the port of Kotka. And since this is an image from January, we have a really, really low sun angle. And this low sun angle means that the shadows are extremely long. And these long shadows help us to have sort of also a side view of the ship, right? We can see that the front superstructure and the back superstructure are really tall. In between, the deck is flat. So this is either an icebreaker with a raised heliport on the front or a cargo ship with a flat deck. This is some of the information we can discern. Or let me give you another low sun angle image. This is Gerald Ford again in the US Navy base in Crete in Suda Bay. And here again we can see the shadows. So we can see that the superstructure is on the left stern of the ship. It casts a special shadow. We can also see the shadows of the structures along the deck. And then exploiting this low sun angle, we can collect a bit more information than what we see from the regular satellite top-down view. Now, a satellite image is going to give you an overview of a specific location. In this case, it's a whole port. And taking a look, we can discern different kinds of activities happening in this port. It's a windy day. You can see the waves. We actually have Bora conditions, the wind coming from the northwest down the mountainside. And now we can start thinking about what these ships are doing. So this ship is definitely active, and you can even see the track as it's churning up the sediment. It's taking a turn. It's probably heading into port. This is the front, this is the back, this is the wake, and you can also see the shadows of the superstructure quite nicely. Probably a container ship because of these little rectangular things on deck. Now, over here inside the port, This ship is obviously heading out, right? Again, you see the mark of the propeller, the wake. The container cranes are just being hoisted away from the ship. And we have a little tug over here, pulling the ship, helping it maneuver out of the harbor. So this is the typical situation of a ship leaving port. So what are these ships doing here? The answer is nothing. If you don't see any wake or any evidence of the propeller moving, and the ship is heading straight into the wind, then the chances it's probably standing at anchor, waiting to enter the port. And then here we have some really fast-moving ships. This is, again, the wake of a ship traveling at a high speed. And over here, yeah, here we are. This is what a ship traveling really, really fast will look like. So it's got waves all along its side. It has a very, very long wake. And again, you can see the structure of the ship. If we move a bit further to the west, from Trieste to Venice, we can explore some small ships. So you know that Venice has regular public transport happening by ships. This is the size of these ships, which are a couple of tens of meters large. So you identify a couple of pixels of them, but nothing much larger. This is a nice signal of a ship turning around under power. So based on the structure, the shape of the ship, and the waves it is generating, we can estimate its heading or the way it's going. So once again, the size of these ships is really, really something special. So ships of several hundred meters moving across our oceans are really having a large effect. This is again Mette, the ship, one of which belongs to the largest container ship class run by Maersk. You can see the more than 400-meter length, the width, which is supposed to be somewhere around 60 meters. So this is the size of these objects moving about. Let me show you another example. This is Icon of the Seas, the largest cruise ship ever built. It was launched a year ago from Finland. And this is just a very recent image from the end of November from Miami. And here you can see the ship. This glass dome in the beginning is a very characteristic thing. You can easily recognize this ship even on a satellite image. And it's very nearly as big as a container ship. So this is 360 meters in size. So again, moving this massive beast of a ship around consumes obviously a lot of energy. A ship with several thousand people on board will have an impact on any city or place where this cruise ship comes to port. But of course, it's an interesting thing to observe. And with satellite imagery, it's also possible to generate a time lapse to observe the process of a ship being built. So if you just click on this little icon here, you can create a time lapse. This is the Meyer shipyard in Turku, where Icon of the Seas was built. And if we go back a couple of months to, let's say, February, then we are getting a series of images. And with this series of images, we can observe the process of the ship being built and fitted out. So now the server is querying all the different pictures from this specific location and the time frame that we set. And as you will see, we can see the process of the ice melting and the ship as it is moved around the dock and as various components are added to it. This is the last couple of months before the ship was sent to the first sea trials. So not that much is changing, but you see as the glass dome is added and the structure of the ship is built. Now let me show you another ship. I think it's an interesting one. This ship here is called, it's probably this ship. I couldn't exactly check, but based on the size and the shape, this is a ship called Orange Ocean. It's actually an orange juice tanker. So it's traveling between Brazil and New York. This is a tanker ship of more than 200 meters in size, and it's filled with orange juice. So the juice you drink may well have traveled inside a massive tanker ship across the ocean. Then again, another way of how ships impact their environment. This is Lake Oroville, a reservoir in the United States. And in this valley or bay, there's a village composed of houseboats. So each of these boats is somewhere around 20-something meters, so like a large house. And they are standing here in a large group, and you can rent them out and people actually live or spend their holidays on these. Well, all this shipping activity does not come without environmental risks. From this guide by Bellingcat, by one of the prominent open source intelligence sites, you can collect information on how to understand oil pollution or oil slicks. Actually, it's even possible to recognize diesel pollution with this rainbow slick effect and crude oil, which is much darker, and the individual shapes. This is crude oil. The individual shapes of the oil slicks depending on the weather. So this is a short guide on how to identify oil pollution on satellite imagery. On true color imagery, the oil pollution is going to be black. On radar imagery, which looks at the structure of the waves, it's creating a flat surface. It's reflecting the energy differently. And there's also a downstream product actually here called Cerulean, SkyTruth. This is a tracking site where satellite imagery is used to automatically identify areas of oil pollution. And you can select them based on size and based on the certainty of the identification, and you can look into specific oil slick events. Let me give you an example here. This is an oil slick that happened off Port Harcourt in North Africa. So this is how the system is identifying the oil slick based on its machine learning algorithm. And if we move in and we look at Sentinel-1 radar imagery, this is what we see. So Sentinel-1 synthetic aperture radar sends down an electromagnetic signal, which is reflected from the surface of the water. And the signal wavelength is somewhere around 5 centimeters. So any waves which have approximately this wavelength or structure will reflect very strongly, and others will reflect in a different way. And so this here, this shadow is the actual ship, and this is the oil slick which is streaming out of it. And it is possible to use various custom scripts, so short pieces of code inside Copernicus Browser for highlighting or automatically identifying these oil slicks. This is another custom script, a different way to visualize it using the oil slicks and red tide monitoring custom script. Then in addition to oil slicks, we also have fishing, which is of course a big activity with a major environmental impact. And I want to introduce to you Global Fishing Watch. This site is combining the ship transponders and the remote sensing-based identification of ships using night lights and using radar. And it's providing an indication of shipping activity around the world's oceans. And if you really zoom in, then it's possible even to look at single ships identified using these techniques. And this is giving you a long-term estimate on the intensity of shipping and fishing activity. It allows you to monitor specific areas. Let me show you another example of a specific incident and how it looks like on satellite imagery. This here is G-Captain, which is just a marine news site. And here I found a recent news feature on a collision and which could have turned out a lot worse that happened recently in the Western Mediterranean Sea. So we have a crude oil tanker, Gloria Maris, a really large one, and the container ship HMM St. Petersburg, and these two collided in the Gibraltar Strait. So what did this actually look like on satellite image? Let me show you, first of all, the two ships, the two players. So this is HMM St. Petersburg. I'm trying to find the size of the ship. Yes, this is another 400-meter massive container ship sailing under the flag of Korea. And this is the other ship, Gloria Maris, 274 meters long. So a large oil tanker. Imagine if this collision would have turned out worse, than there would have been an oil leak that would have really caused a major problem in this region of the Mediterranean. And this is actually a satellite image on the day of the incident. And we see these two ships, which are behaving differently than the others, right? They are moving in a curve, so they're performing some sort of a maneuver. And they're also moving under less power than the larger ships that you see near the ports, which are actively moving. And based on their sizes, it's possible to identify that this is St. Petersburg. And this here is Gloria Maris. So in this case, we have lucky conditions. We have an overpass, well, not exactly during the incident, but shortly after it when the ships are heading away to the port after the collision. Of course, a lot of shipping-related open source intelligence connects to war, unfortunately. And this is an example from an attack that happened during the Russian invasion of Ukraine in the port of Berdiansk. I am showing you this because at the time of the attack, contradicting information was available on the internet, whether the ship was actually hit, what kind of ship this was, how many ships were damaged, and what the cause of the incident was. But quite obviously, what you see is a big smoke column rising partly from the buildings on the shore and partly from a ship that's on the water. And we also see evidence of ships moving very fast out of the port. We don't see those ships there outside the image, but this actually happened. And then if we want to address the question whether the ship was sunk or what actually happened to it, we have to look at the next satellite image. And we see this image of a ship sort of semi-submerged, but still close to the pier. The size matches the Tapir-class landing ship. We can measure that. And so based on this information, it's possible to verify at least the effect of this incident. Now moving forward to sort of happier topic. This is an image of the English Channel. And it's not a single individual satellite image, but it's a composite of an image, of a set of images collected over a month. So what you see is the ships moving along these shipping lanes, this whole crowd of ships. As said, each of these images is a detection on a specific image. So it's not that all of these ships were there at the same time. Most probably a ship will be imaged several times during this monthly composite, but what you see is the shipping lane itself. These are wind power stations in these sort of periodic shapes across the shallow part of the North Sea. This is what a monthly composite of a shipping lane looks like. And now let me show you a really busy place. This is the port of Singapore. This is not a monthly composite. This is an individual image. So this is the density of large ships which regularly stands around in the port of Singapore. So maneuvering, going to the docks, loading and unloading ships is a really, really risky business when you have this level of traffic. And in the middle of this activity here is a very, very special ship docked at the marina. It's just over 100 meters long, and it's actually a sailing ship. This is Amerigo Vespucci, a training ship of the Italian Navy, which is doing a world tour right now. Unfortunately, I couldn't grab a true color image of it that would really show you the shape of this ship, but we can identify based on the knowledge on the ship's location that this is Amerigo Vespucci. Sailing ships are special. They don't generate wakes. So this is the America's Cup, one of the most important sailing races of the world. And these two ships here are the ones which are the actual contenders. These two are motorboats traveling at approximately the same speed as the racing ships. And you can see that the sailing ships generate much less waves, obviously, since they don't have a propeller. Another sailing ship here, this is the port of Klaipeda during the tall ships race. And this big ship here, it's about 100 meters long. It's probably Statsraad Lemkuhl, so a Norwegian tall ship, more than 100 years old, which took part in the race. Over here, this is Royal Clipper. This is a four-masted cruise ship. Again, a relatively rare find for satellite images cruising in the Caribbean. And to wrap up very quickly, the story of the space speedometer, how to estimate the speed of a ship. Based on generic physics, we know about these Kelvin waves, which are a regular phenomenon of anything that's moving through water. And the wavelength of these Kelvin waves is closely proportional to the speed the ship is traveling at. So with relatively basic mathematics, it's possible to figure out the speed of a ship if these waves are visible on the satellite imagery. Let me give you an example. This is the Mols-Linien Express traveling from Aarhus to Sjællands Odde in Denmark. And what we see here is it's left the port here, it's traveling in that direction. And you can measure the length of the first wave over here, which goes up to 130 meters. And based on this, it turns out that the ship speed is somewhere between 25 and 30 knots, which is actually not the maximum cruise speed of this ship, because it can travel up to 40 knots, but it's a relatively high speed that you can measure. This is what I wanted to take you through, and I'm ready to take your questions. Thank you for bearing with me. The main question, upgrading the resolution. Sentinel-2, so open source true color satellite imagery, has this 10-meter resolution. It's the spatial resolution that you get, but you get it every 5 days. There are commercial satellite operators out there who collect imagery in a lot higher resolution, some of them at less temporal frequency, some of them at very high temporal frequency, but you have to pay for those images.
We have another question, Andras. When marine traffic and vessel finder don't provide information, how can one gain insights into ships' non-shiners?
Well, what I just showed you was the free version of Marine Traffic and Vessel Finder. Actually, if you subscribe, then it's possible to collect AIS information also from ships which are outside the range of the shore, so where satellites are actually transmitting the information, and also to uncover historic imagery and historic AIS data to learn about the position of a ship a week or a month or several years ago. But of course, we have ships which cheat, which don't carry a transponder, or they somehow hack the transponder. And this is the exciting part, when you can actually prove that this is happening by showing that a specific ship was in a place despite their transponder saying something else.
There is one more question. Is there API for manipulation with images?
Oh, yes. Thank you for that question. Copernicus data space ecosystem is mainly built around the concept of APIs. So we have the browser, which is an easy interface to look at images, but using the APIs Sentinel Hub and OpenEO, which are available in Copernicus data space ecosystem, and actually the free cloud computing quota, it's possible to build analysis pipelines that you can operationally use.
So there we have one more question in chat. If you can give some examples of illegal activities and also floating debris using Sentinel-2.
Well, I can give you an example of marine debris. This is the ocean plastic detector prototype script from the Sentinel Hub custom script. And this is just a small example of it in Greece. I hope it will load in time. This little tool uses various spectral bands of the image to detect marine plastic, floating marine debris, using some spectral analysis. There are many different illegal activities that you can uncover. I mean, the most important one is definitely the traveling of ships without a transponder. I've seen a question in the chat about Analysis Ready imagery time series. Yes, that's also available. Let me go back to the browser. So this is level 2 imagery, which is Analysis Ready. It is already corrected for atmospheric and geometric effects. This is level 1 imagery, which is raw. And then we also have level 3. So you can see that it's sort of hazier. And then we also have level 3 monthly composites, Sentinel-2 mosaics, which are absolutely Analysis Ready. All the clouds and all the noise are removed. But then the time frame for each of these is once every 3 months for Sentinel-2 and once every month for Sentinel-1. But these are definitely Analysis Ready. So this is loading.
Thank you, Andras. I think we came to the end of our time for this webinar. If you have more questions, I would welcome you to use our Copernicus Data Space Ecosystem forum for asking them there. I invite you to stay tuned and follow our social media for future webinars. Thank you, Andras, again for your presentation, and to all of you for joining us today, and see you the next time.
Thank you.